All right, advanced geometry, welcome. Here we are, home learning, crushing it. This is, lesson 12D, I think is what I called it in Schoology, and we're going to talk about section 12.4 out of your textbook, which is the law of cosines. So in the beginning of this unit, we talked about using sine, cosine, and tangent ratios to solve for missing sides or angles in right triangles. And then last lesson, we talked about the law of sines, which allowed you to solve for sides or angles in oblique or non-right triangles. And the law of cosines is very similar to that, in that you don't have to have a right triangle to solve for missing sides or angles. So take a look. Here I have my little triangle here. It's oblique. It's not necessarily a right triangle. So what we're going to do is we're going to derive the law of cosines. And the way we're going to do that is based on what we did back in chapter 9 by using what's called a Pythagorean system. So let me go ahead and set this up for you guys. Anything that deals with sine or cosine or tangent typically is derived by using a right triangle. So that's what we're going to do. So I'm going to cut this into two right triangles, just like I did when I derived the law of sines. And the way we set things up will just be slightly different. All right, I'm still going to call this guy here H, and maybe I'll call this guy X. And just like you guys remember, if this entire length is B, and I call this little piece X, then this is going to be B minus X. So what I'm going to do is I'm going to set up a system, or a Pythagorean system, like we did in chapter 9. So this will be triangle 1 here, and this will be right triangle number 2. So for triangle number 1, the Pythagorean relationship that exists is that x squared plus h squared is equal to a squared. All right, we can't go any further there, so we're going to stop. In triangle number 2 over here, the Pythagorean system that exists, or relationship that exists, rather, is that b minus x squared plus h squared is equal to c squared. Now this I'm going to simplify a little bit more. Now remember, when you square a binomial, it's the same thing as multiplying it by itself. So I'll show my work for what I'm going to do up here. So that'll give me b squared minus bx minus another bx, so that'd be minus 2bx, and then plus x squared. So I'm going to take this binomial that's being squared, and I'm going to turn it into what you get when you square it. B squared minus 2bx plus x squared. And then I still have my plus h squared, and that equals c squared. Now what you learned in chapter 9, and hopefully you remember, especially those of you who are going to earn some chapter 9 test points back because there's a Pythagorean system on that worksheet, is that we're now going to substitute for x squared plus h squared, which is equal to a squared. So over here in this equation, wherever I see x squared plus h squared, I'm going to replace that with a squared. So I end up with b squared minus 2bx plus a squared equals c squared. And now I'm really close to setting up what's called the law of cosines. I'm going to move some things around here. So I'm going to rewrite this by using the commutative property of addition that allows me to kind of rearrange the order. So I have a squared plus b squared minus 2bx equals c squared. And then the last thing is, you'll notice in the very beginning of this problem, x and h didn't exist. Now I was able to get rid of the x squared, I was able to get rid of the h squared, but I still have this x here. So I need to come up with some relationship that allows me to get rid of x and replace it with one of the original values in this triangle. And in this triangle, the original values were side lengths of a, b, and c, and then angles a, b, and c. So I'm going to use triangle 1, and I'm going to use cosine and say, okay, well, the cosine of c is equal to adjacent, which is x, over the hypotenuse, which is a. And then if I multiply both sides by a, I get a times the cosine of c is equal to x. So now what I'm going to do is I'm going to substitute yet again. So instead of x, I'm going to put a times the cosine of c in its place. So that will give me a squared plus b squared minus 2b, and then instead of x, I have a times the cosine of c. And then the last thing I'm going to do is I'm going to use the commutative property of multiplication and just swap this a and b. And the reason I'm going to do that is simply because that's how this works. All right, so here's, and I forgot it was equal to c squared. So the form of the law of cosines looks like this. c squared equals a squared plus b squared minus, and I'm going to rearrange the a and the b by using the commutative property. So 2ab times the cosine of c. That, my friends, is the derivation of the law of cosines. And I think it's important, especially in an advanced math class, for you guys to understand where this stuff comes from. So all this was an application of was a couple things you've already learned. One, how to do a Pythagorean system, and two, what cosine is for a right triangle. And by doing that, I was able to establish this relationship. So now if I go back and look at the original triangle, what this tells me that I can find this length, c squared, I can find it by taking a squared plus b squared, so I'd plug in here and here, minus 2 times those same values, a and b, times the cosine of this angle, c. There you go. Now I have established that relationship, and in the next video, we'll actually practice it. All right.